section 4.4 on parallel and perpendicular lines. In this section, we're going to be writing linear equations in slope-intercept form, just like we were back in section 4.2. But this time, they're going to focus on lines that are parallel or lines that are perpendicular. For today's lesson, our focus is only on those lines that are parallel. First of all, what are parallel lines? Lines that never touch. So in your notes, if I was you, I would draw an example. Two lines that are parallel are lines that never touch. They're going to run side by side forever. They'll never meet, they'll never cross. Can you think of some things, like some real life things that are parallel lines? Railroad tracks are a good example, don't they? Like the edges of the railroad track, they run parallel to one another all the way through the country, right? What are some other things that are parallel? Maybe?
The rails on some stairs.
The what?
The rails on some stairs.
Yeah, the rails, like the handrails on some stairs, they would be parallel lines. What about the lanes of a track? Like on our track out here, don't the lanes run parallel to one another? Here's some examples. I have the Twin Tower Memorial. Let's see. Those parallel lines represent the Twin Towers that one stood. Railroad tracks. The bricks on the wall. Those lines are parallel to one another. Tiles on the floor. Lots of things that are parallel to one another. So we said lines that are parallel are lines that run side by side. But in terms of math, we're going to say that their slopes are the same. Please put this into your notes. Parallel lines have slopes that are the same. Parallel lines have slopes that are the same. Pencil keep breaking?
Yeah.
Do you want another one?
Yeah.
Alright, so we're going to look at some problems where they're going to give us some information and they're going to talk about parallel lines. Let me give you an example of what I'm talking about. It says to write an equation in slope-intercept form for the line that passes through negative 3, 5 and is parallel to the graph of y equals 2x minus 4. Okay, so for our notes purposes, I want you to write a couple of things down. In your notes, please put the ordered pair, negative 3, comma, 5. And beside that, I want you just to draw two parallel lines. Okay, two parallel lines. And we're going to write the equation y equals 2x minus 4. So when we look back at this problem in our notes, we'll have some idea of what we're talking about. Our line goes through negative 3, 5, and it's parallel to y equals 2x minus 4. Alright, so I just told you that two lines that are parallel have the same slope. What's the slope of this equation, y equals 2x minus 4? 2. Go ahead and circle 2. 2 is our slope. And I'm going to write m equals 2. If I have an ordered pair and I have the slope, could I write the equation of this line? Absolutely, that's what we did previously, isn't it? So let's take our point and our slope and write an equation. What piece are we missing? The b. We have to find b. So we have an ordered pair, so we'll say 5 equals our slope, which is m, times x, negative 3, plus b. 2 times negative 3 is negative 6. We're finding b, so I want to add 6 to both sides. So b is 11. So now that I have my y-intercept, I want to write an equation using my slope and my y-intercept. So y equals 2x plus 11. So I'm going to open Desmos real quick. And what I want to do is I want to prove to you guys that that equation and that equation really are parallel. And that our equation right here, it really goes through the point of negative 2, 5. We talked about decimals in here the other day, didn't we? Or the equations? I think we did, yeah. So, y equals 2x minus 4. That was the original equation that we had. We said that our line was parallel to this one. The line of the equation we created was y equals 2x plus 11. Are those two lines parallel? Look like it. I can zoom out further and further away. They're always going to be parallel, aren't they? Okay. Now, does our line go through that point, negative 3, 5? Okay, here's negative 3 right here. Negative 3, 5 would be right here. There we go. Does our line go through negative 3, 5? Absolutely. So we're just proving here that our lines really are parallel and that the line of the equation we just wrote really went through the point of negative 3, 5. Okay, let's try another one. It says to write an equation in slope-intercept form for the line that passes through 4, negative 1 and is parallel to the graph of y equals 1/4 x plus 7. So in your notes, I want you to write down the ordered pair, 4, negative 1. Write down the ordered pair, 4, negative 1. And I want you to write two, or draw two parallel lines, and then write the equation y equals 1/4 x plus 7. That way you know what the problem was. Now, they told us that our lines were parallel. We know that two parallel lines have the same slope. So what's the slope of our equation going to be? Very good. It's going to be 1/4. Go ahead and circle 1/4. That's our slope. So we have a slope and we have an ordered pair. Could we write an equation? Absolutely. Let's do that. So y is negative 1 equals m 1/4 times x 4 plus b. 1/4 of 4 is 1. If I want to get b by itself, I'm going to subtract 1 from both sides. So b is negative 2. If I know my slope and my y-intercept, could I write an equation? Absolutely. So we have y equals 1/4 x minus 2. Again, for this one, I'm going to graph it on Desmos just so you guys can see the comparison. See that they really are parallel, and we can check to see that our line goes through 4, negative 1. So our original equation (1/4 x plus 7), and our equation is y equals 1/4 x minus 2. Okay, got our two equations. We can see that they really are parallel, aren't they? Does our line go through the point of 4, negative 1? Here's 4. 4, negative 1. You can see right there that our line really goes through 4, negative 1. Now, it would make sense that two parallel lines have the same slope, right? Because what is slope describing? The angle, right? The steepness, how steep our graph is. If they have the same steepness, that would make sense that their slants are the same. They have the same slope. I want you guys to try this one. It says to write an equation in slope-intercept form for the line that passes through 4, negative 2, and is parallel to the graph of y equals 1/2 x minus 7. So in your notes, go ahead and write down the ordered pair, 4, -2. Parallel lines, and y equals 1/2 x minus 7. Okay, in this case, we knew that our slope was going to be 1/2. And we had to find our y-intercept. So we used our ordered pair and our slope to help us with that. Half of 4 is 2. If I want to get b by itself, I would subtract 2. So b is -4. So my equation should be y equals 1/2 x minus 4. Parallel lines have the same slope. We can find an equation of a line that's parallel by using the process that we learned back in section 4.2. Find m, find b, write your equation. That's where I'm going to stop for today. We're only focusing on parallel lines. Tomorrow, we will look at perpendicular lines. You need a textbook. If you don't have one, go and grab one.